Okay, good morning and welcome to this morning's panel discussion, Design for Manufacturing and Closing the DFM Loop. For many years, engineers have struggled with getting the information back to the designer to avoid having too many turns into production. But nowadays, with new technology, new software coming into the market, we're actually reaching that holy grail where we can really close the loop on design for manufacturing. And here to discuss that with me this morning are three very distinguished panelists. We have Michael Ford from Aegis, nice to see Michael, Jay Gorajai from Siemens Mentor, and Hemant Shah from Cadence. Nice to see you, Hemant. So thank you for joining me, gentlemen. Let's start with the first question, which is basically with the introduction of Hermes CFX. Do you think this is giving the industry the platform to really start to build systems for the future?
Yeah, it really is the first time that you can start to collect information from the various processes around the shop floor. I mean, CFX is going the whole gamut of the different machine types, gathering data into precise detail. And you know, this is the exact kind of data that you need to be able to understand the performance of, for example, design features, manufacturing operations, and also materials that were selected.
Right.
So being able to gather that information and be able to understand, though, the causes around any kind of lost opportunity is essential as a feedback then into the design process.
Yeah, yeah. And I know for a lot of vendors out here with equipment, it's a great leveler because it means they're not having to spend so much time writing software patches every time they sell a piece of equipment. You have different software at Siemens Mentor, Jay. I mean, how does it help you or impact your job?
I think, first of all, to have standards is excellent. Mm-hmm. And as Michael said, with the CFX IPC standard, it will allow vendors to kind of collaborate a little bit more, which will be excellent. Each vendor today, anyway, has their own internal formats, and they'll continue to evolve those as well. Mm-hmm. They're coming out with their own capabilities, and they'll evolve those as well. So I think the other piece to this discussion, in addition to CFX, which is doing some good work on the SMT equipment and testers and things like that, we'll also have to start looking into short-term versus long-term. Mm-hmm. There's no doubt that standards is a long-term play, right? We need to be here to establish something now so that at some point in the future we can truly benefit from a harmonized environment, a normalized environment.
Right.
But you know, most factories today is kind of a hodgepodge of ages, right? Old equipment, mm-hmm. medium-aged equipment, brand new equipment. And, you know, we also need to find solutions to those. Yeah. You know, and CFX is one of them. Mm-hmm. You know, in addition to our solution and Aegis' solution and the various other third-party solutions out there, we're using it as CFX to potentially communicate to the new stuff. We have other methods to communicate to the old stuff, and we still will need to do that. We have Valor IoT to do that, and so on. I think the other piece to the conversation, though, is it's only a small piece of the full production. Mm-hmm. We also need to think about how, as an industry, we want to take all of it. Let's be honest. The PCB assembly has to go into something.
Yeah.
And those are mechanical and plastics, and how is all that going to be? And those standards are completely different, you know, and maybe we need to start saying, all right, there's OPC UA for all those PLCs out there, there's, you know, this and this, and so our customers, and I think the manufacturers and the OEMs are looking for probably a nice total solution, and I think we've taken the first step.
Right. Well, I think it is a useful first step, and I think obviously it will evolve as requirements.
Well, if I may, actually CFX is not only for S&T. We've got a demonstration upstairs where it goes throughout the whole gamut of assembly all the way to final box build. And you know, even non-electronic mechanical areas are embracing it. Even semiconductors are talking to IPC now about. So because we've defined the content of the messages, which is absolutely unique as part of any standard of any of these things that we've spoken about.
Right.
This is what is driving it beyond those kind of confines.
Confines, okay. Hemant, you're more involved directly at the design end of the equation here. How does the CFX Hermes software, does that impact what you do at all?
Yeah, absolutely. Actually, CFX is a very good standard, and like Michael said, it covers the whole gamut. CFX as a standard needs the digital product model to go build it. And one of the things that, from the design side of things, that we've been focused on through the IPC 2581 consortium is to ensure that the data is intelligently passed on from the design to manufacturing, right? And 2581 fills that gap, right? It's an open standard, it's not owned by anybody else, and it has the complete data that you need, complete model. You know, in the past, and even today, a lot of people tend to take that intelligent design data and dumb it down to Gerber and a whole bunch of files. And then somebody else has to reverse engineer that to intelligent data again. And that's just, in this day and age, it doesn't make sense.
Doesn't make sense.
So that's one part of it. The second part of it that you started out by saying is, how do you take that data back from manufacturing into design? Well, if you have a design intelligent vehicle, you can annotate that data back into that intelligent product model and bring it back to the design, where the person doesn't have to look at a PDF document, find the specific reference of an object or a layer that you're talking about, and then correlate the, sort of paper document, if you will, into the actual specific area where the design is having trouble. By having that data from the manufacturing floor annotated in the intelligent product model, it makes it very easy to focus in on where the problem is and what the fix is. And you can close the loop very quickly. I think it's important to start the whole DFM journey from the design side of things and bring it back to the design side of things. And of course, CFX is a key thing to enable that on the factory floor, because without it, you won't have the intelligent product model back again.
Of course, yeah, you need that platform to start the journey. And yeah, interesting stuff. Taking it, building upon the IPC CFX products, you have a lot of companies have their own bespoke software. You have Panasim with their Panasonic factory software, you have Yamaha with theirs, you have Nexim for Fuji, etc. But then you also have things like Factory Logics that you're offering, and you have your own offerings as well with Siemens Mentor. How do they integrate into this?
Basically, any software that's been designed or developed more than 10 years ago is extremely unlikely to be able to take full advantage of these new kind of technologies. I mean, IoT is a whole different way of exchanging data. It's not just simply an interface, here you go, there's some data, go use it. It's a fully interactive environment. So uniquely for Aegis in the industry, just a couple of years ago, when we designed from scratch our Factory Logics platform, it was with this goal in mind. It was exactly to satisfy these advances in the industry. And it is extremely difficult to replicate that from older software. You just don't have the ability to do anything beyond the simple reporting of the data. So I don't know if it was luck or what, I'm sure it was intentional, that we've positioned ourselves as this digital MES leg going forward, which is designed to bring the maximum value from this new technology.
Right, well, we'll talk about the MES stuff going forward for sure. What would be the benefits though for companies wanting to use Factory Logics versus some of these other systems?
We want to have a true visibility for people. In that they are able, at one end of the spectrum, maybe we're making spaceships and satellite boards where people need ultimate traceability. CFX delivers that, Factory Logics absorbs that and builds it into a digital platform. So at the opposite end of the scale, you're building maybe a USB device, people need to be very, very agile and flexible in changing their manufacturing. Well, CFX does the same thing. It provides that data, Factory Logics absorbs that data and makes maximum use from the visibility of what is going on. Really empowering our people in manufacturing, people with experience to make decisions, really empowering to improve those decisions in terms of really doing it rapidly and accurately without risk.
Jay, I would ask you the same question, but you go into a lot of factories today and they've got their own homegrown software. And they're very, they guard it very jealously because they regard that as their IP, differentiator. So why should they consider looking at maybe the Siemens Mentor option?
I guess it's the same question for, why would they look at Factory Logics, or why would they look at Panasim or anything, right? It's the core to the benefits has a lot to do a little bit with what Michael alluded to, which was creating the digital twin of the factory, of the product, of the processes, and enabling that within your software, whether it's whatever software it is, modern as it should be. They are looking now to not just execute. Right. That was the old days. Oh, I've got this work order, let me get it done. Now it's, is my plant organized in a way that's most efficient for material flow? Right. Is my line defined and organized in the best way to do outputs for the different types of products that are coming in? Are these areas, as either a contract manufacturer, these are the areas that I'm focused on building as a customer base? Is that optimal? Right. And we're looking at not just the execution piece, which is important, but how do we do process simulation and plant level simulation, and how do we embed, for example, robotics and robotic simulation? Is there a play here to simulate the opportunity to add additive manufacturing components within the strategy of building a factory to be its most efficient? And I'll give you an example of how that is. We're working with a factory now where, as everyone knows, you have to build fixtures and you have to build tooling and you have to build all those things. It's part of doing business, right? Yeah. There's a catch-22 with those, because if you're trying to do low volume, high mix, and then still need to build fixtures and so on for repeatability and to get the quality in there, it's at a crossroads. Right. But that's where additive manufacturing can come in and say, I can build that fixture for you. This is the way it would be. In 6 hours, it's built something that you can build with at batches of, let's say, 200 parts using that fixture, right, and you're all right. So we're thinking about it a little more than just, okay, I have a work order to execute. I think we're trying to now say, it's good, been there, done that. Most people can do that. Right. Now let's start talking about how do we raise it up to say, are we working in the most efficient manner for our business? Is the process within the factory floor? Is the plant? Is the line setups? Are we using the technologies that are out there to optimize the margins as much as we can to eke out that extra 3, 5, 7%, right, if even that, so that we can survive, grow, and maintain our differentiation. Right. And these are the areas that are differentiating. I mean, we've been to factories in which they're building rows of robotics for that final mile, right? Right. We built everything else, hand place is great, but now I need robots at the far end. How do you simulate those? Right. How is it the right way? And if robots are going to be standing next to humans, how do we ensure that they're not going to get hurt? So we've got technologies, and we're working on technologies to optimize, simulate.
So you can simulate all the different functions.
Right, and then virtually commission that. So once we've simulated it, then we can push out the robotics program, we can push out the additive lattice programs and so on, and kind of make it a centralized planning function rather than just focus on the execution, which, I mean, those are table stakes, right? Everyone has to do it.
Yeah. No, I mean, it's very true. I mean, you've got the line optimization, which is first pass yield and that type of thing, but then, of course, it's the optimization of the factory space itself, limiting machine downtime, all these types of things that are really going to bring the value into the equation.
Exactly.
So let's bring in Hemant here to have his input on this.
Yeah, so what's interesting is we started the conversation about design for manufacturing, you know, and one of the things that is happening in the industry is it's really, we're following the 1980s process where the manufacturers provide their manufacturing rules to the design houses in paper form, right? Essentially a PDF document, right? And that PDF document then has to be interpreted by the design house and then converted into rules that are then entered into the design tool. This is really an archaic process, right? The better way of doing that is to provide their rules electronically.
Yeah.
So what Cadence did at PCB West last year, we launched a new program called Design True Partner Program, which allows the manufacturer to provide their rules to their customers electronically that can plug into the design tools without any interpretation, number one. Number two, it also enables the customers to go ask multiple manufacturers for their rules electronically rather than pick up the phone and call somebody. And a lot of large companies have the infrastructure to do that, where they have the relationships and get that. But the majority of the companies don't have that group or infrastructure. And so what it does is enables the electronic exchange confidentially between the design house and the manufacturing partner. And what that does is now the design is being done according to the manufacturer rules. The other innovation that we announced earlier before PCB West was real-time DFM checking. Because often the state of the industry was you do the design, at some point in time, at some milestone, you go batch DFM check, find the problem, go fix it. But as you know, the later in the design you find the problem, it's more expensive to fix it. And the best place to fix it as soon as you make it.
Yeah, most boards end up with 5 or 6 turns before it actually gets into
Correct,
production.
exactly.
Yeah.
By designing to the manufacturer's rules and finding errors in real time, it makes it really easy for the design to be ready for manufacturing. So you get a better data, a better handoff through 2581. But it's very important to have real-time DFM check in the design house and the ability to get the manufacturer's rule into the design tools without any human intervention.
Right, no, I agree. Michael, if I could turn my attention now to MES, I mentioned it when you mentioned it a moment ago. That's been your most recent acquisition with Aegis, or introduction, should I say? It wasn't an acquisition. But it seems to be a trend in the industry. ASM acquired an MES company. Mentor integrated with Siemens, which has an MES offering. Is that the way forward? And is it trying to drive some of the middlemen and middleware out of the industry?
It's a bit of a desperate situation, to be honest, because the world is changing now. I mean, we were talking about simulation and optimization, and these are all great things to do for capacity planning over a long period of time. But the reality is that the industry can't do that anymore. We're talking now about Industry 4.0, where we need to be really flexible and do a different thing every day. I mean, even Siemens, in part of Industry 4.0, they should know that. Every day sees a different customer demand. So you can't optimize effectively in a long term, or even plan effectively in the long term. Where we see the industry going is being extremely flexible, but at the same time, extremely efficient. So using information that you have from CFX or wherever on a digital platform that makes these decisions immediately. That is the real kind of practical tool that manufacturing needs to going forward. And it links with the design feedback as well. Because as soon as something happens, you need to know about it immediately, because all of the time that's taken to find out what the problem was is loss. And you just cannot afford loss in today's modern immediate manufacturing. So I think that as people are scrabbling to find solutions based on old software or middleware that they find in the industry, they're realizing that, first of all, it just doesn't work according to the needs of modern manufacturing. And in fact, it's introducing layers that aren't even necessary. I mean, with CFX, one of the key things is that machine vendors and processors produce native data. There's no middleware there to interpret it, to have to develop and evolve it. There's no middleman to argue when it doesn't work. It simply does work. I mean, the trial here, for example, the demonstration, we got, I think, 33 companies involved. Not one business trip, not one NDA, not one technical discussion. It just was developed by machine vendors and it works. This is the new age of digital manufacturing that we really need to get towards. And okay, it's great to consider the future for these huge-sized factories within Siemens, and that's fine. But most people today are facing the challenge of Industry 4.0. They need to react extremely quickly.
So it needs to be plug and play, basically. Everything just needs to work.
And the
But, I mean,
conversation, and the conversation about being plug and play, I think is, that's where we are today.
Right.
Obviously, being flexible doesn't mean they move machines around every day either. So they want to optimize their factory. Yeah, right. But I think it's key, and Michael, I agree with Michael in the sense that it's absolutely critical to have the flexibility to ensure that whatever you are building of that minute of day, because it is Industry 4.0 and it could change every day, is being done in the most efficient manner. So it's great that we can collect all this information, but we need to ensure that there's value in that information, and that information is being brought into an environment that has the ability, the capacity to analyze and create that efficiency, so you're not just making the same mistakes over and over and over again.
Right.
And I think this goes back to Hemant's point about really connecting to the factory floor and understanding what went wrong and what's best. As manufacturers identify that this is the best way to have an outcome in our factory, can you at least build to that?
Right.
That will severely improve the quality of these products. We're not going to have as many, stops and however they feed that back. I mean, you can have this automated electronic format, and which is great, because it's kind of sad that, I agree with you, it's very sad that today we have to exchange, what's that called again? Oh, paper, yeah. We have to exchange that paper thing again. And that's the state of the union right now, right? It's the way people are working, and it's unfortunate. And I think what Hemant started with their innovations is the beginning of an evolution there as well.
Right.
But
I mean, I think the plug and play concept is great going forward for all new equipment that's coming on the market. But of course, we know the reality of the situation in Europe and the US especially is there's a lot of legacy equipment out there that are probably still going to need some third-party middleware to make them work.
The overriding priority is for machine vendors to develop things natively, and IPC has made that very, very easy by providing the software development kit. We had one vendor on here who within 1 hour had ported CFX into their machine. So it's not a huge problem to go back to some of the older machines, but it's true. There will be some machines, especially outside of electronics, that have never really considered anything smart. I mean, they're still using PLCs or OPC or something like that, and they want to get up to join electronics. After all, most products have electronics and mechanical components. They need a level playing field throughout. So there are a number of companies, one of which of course is Seika, who have a little white box, extremely cheap, a little Raspberry Pi computer inside. So just for a few dollars you can actually connect to a really old machine. As a company, Metcal, they put CFX onto a chip which is 5mm square running a Linux client. And it costs like $14, I think it's $9 now, to put that into their soldering iron. It's amazing what you can do with modern technology. And this breaks down these barriers that we've seen, which have really been going on for a long time in the past. But we need to break free of these shackles, of this old thinking about how to connect to machines, and really go forward now with the technology that is available.
Right. No, I agree. Hemant, have you got any input on this side of the discussion?
Yeah, I think one part that the way you need to think about is that I mentioned earlier that you have the digital product model that plugs into CFX, and it's the same digital model that can bring the data back in into the design, because it's important to find things that can optimize the flow if you could tweak the design. And it's important to bring that data back.
Yeah.
You know, what is it that's slowing down? What is it? What are kind of errors you're finding out? So what we find out working with different manufacturers is that there are things that are designed according to the rules, and yet if there was a small change made, the efficiency of the manufacturing line can improve tremendously.
Mm-hmm.
It's that kind of data that needs to be fed back so that the next design that comes in can be more efficient, beneficial for the manufacturer and beneficial for the design house.
So how close are we to achieving real DFM?
So
Are we there today?
So real DFM on the design side, yes, right. I think we in the Design True Partner Program that I mentioned, we have several manufacturers that are part of it, and many customers have requested 169, 170 requests to get rules since October, November kind of time frame. That just shows you the volume of requests from design houses to manufacturers to get the rules. They can suck it in electronically. So that's happening on the design side now. We need more manufacturers to get on providing electronically executable design rules, because that's the starting point, right? And you got to go back up, up the stream to prevent the problems from happening instead of addressing it on the manufacturing floor.
Okay.
Yeah, this is a classic example, actually, of how data from manufacturing can be used, because people who are creating these rules, I mean, for either of your product, it basically depends on their knowledge of manufacturing and of materials selection and the processes that happen. And they don't understand manufacturing. They don't understand the technology of the different machines, the testers and the formats and all of this kind of stuff. They are basically design experts. That's what you pay them for. So if they can get the kind of feedback on the performance of a design element on a PCB, because they've had the digital product model from 2581 fed through, and they're using it to manage the line, that they're referring to that, they're following the programs that information provides, and then they can see the direct result of what happens at that process. But then it's reflected back through 2581 from CFX in a way that the designers will understand. So we've removed all the technical jargon and all of the stuff that they couldn't possibly, expect to know, and simply presented an opportunity to create a rule in the way that they understand. So
I think that's the next step, really. I mean, once we optimize the manufacturing line, the next step is obviously going to be to map and characterize the materials behavior.
Right. And I think the next evolution of DFM, once we settle on the somewhat static correlations, this type of component on this type of a board with these characteristics are resulting in this, and so make these my rules, into more of a dynamic characterization of the process. Because right now what we're referring to is more product related correlations. This type of product with this type of component with these material definitions, this is the result, this is what I should do. The next evolution in DFM is about process correlation. I have built 100,000 of this type of material with these correlation of component types, and these have been my results with some sort of a machine learning algorithm that says, now I'm able to identify that when I see these occurrences again, there's a 90+% likelihood that I'm going to have an error. And that is a process characteristic based on not necessarily the exact equipment, but let's say the profiles of the equipment, the characteristics of the materials, raw materials, this type of solderability, this type of output definitions, and then start building not necessarily a mapping that we're doing today in paper or exchanged electronically, but more about, if I'm building this type of a product, run me an analysis of all the millions of boards I've done before, identify the characteristics that are common to this and
Yep.
what have been those outcomes and what should I adjust. That should be the next level of DFM,
Yeah, we-
especially in the design
Yeah,
space.
we've got a panel discussion on Thursday discussing the next stages for materials mapping. But you're absolutely right. I mean, for example, companies like Henkel know how a Henkel solder will work with a Henkel underfill and this type of thing, but they don't know how it'll work with an Indian board finish or from another brand, and that barrier needs to be broken down. We need to be able to fully understand how these materials interact with each other. Hemant.
So I think Jay brings up a good point that there's a lot of data on the manufacturing floor that can be acted upon. You can apply AI and machine learning techniques to it. What would be better then is to take that knowledge and change the manufacturing rules that you provide the design house, number
Yep.
one, right? So essentially, if you can correlate that and say, I need to tweak this manufacturing rule that I need to give to my customers who are going to build their designs. The second portion of it is that for a specific design that's completely done, today that design is handed off and there's the DFM iterations that are unnecessary, totally avoidable, right? But tomorrow with this data, you can put that into the manufacturer system and say, given this configuration of components to be placed and the way I have to build this board, I need to change something. Maybe move a tall component further away from the edge of the board or something.
Yeah.
So it's designed correctly according to the rules you provided to the customer, but given the configuration of the board, now I can provide additional data and say, if you were to tweak this design slightly this much, yes, it'll cost you something, but it'll save you much more during the manufacturing process. Now it's worth it for the people to do.
Yeah, I agree. Gentlemen, we've run right out of time. It's a great subject, and I'm sure we could talk about it for hours. But right now, I want to thank you all for joining us. Michael Ford from Aegis. Thank you. Okay. Jay Gorajai from Siemens Mentor.
Thank
and
you.
of course, Hemant from Cadence.
Thank you.
Cadence,
Thank you
should
very
I say.
much.
All right, thank you for joining us, and thank you for watching.